An engine is assembled from numerous metal parts, many of which rotate at high speed under high temperature conditions. If these parts are not lubricated, they generate heat due to friction, causing wear or seizure. The lubrication system is indispensable for smooth engine operation. The lubrication system is composed mainly of an oil pan to store engine oil, an oil pump to pressure feed the oil to various parts of the engine, an oil filter to remove impurities from the oil, and an oil cooler. The lubrication system supplies engine oil to each part of the engine so as to force an oil film on part surfaces, thereby minimizing friction and wear. Parts thus lubricated rotate or slide smoothly, enabling optimal engine performance. Four-stroke engines normally use a pressure-type lubrication system. In this type of system, engine oil stored in the oil pan is first filtered through the oil strainer and then sent to the oil pump. The oil pumped up by the oil pump is further filtered through the oil filter and sent through the main oil gallery of the cylinder block to each crank journal and crank pin of the crankshaft. The oil is jetted out to lubricate the pistons and cylinders. Simultaneously, oil is supplied to the valve mechanism. The oil is then returned to the oil pan. Now, let's look at each major part of the lubricating system. A trochoid pump is usually used to pump oil. The procedure of oil pressure feed is as follows. The drive and driven rotors rotate while interlocked. Since the drive rotor shaft is slightly eccentric, a space is produced between the two rotors as they rotate. The oil is pressure supplied through this space. The oil pump has a relief valve which adjusts the maximum oil pressure. When the oil pressure reaches a specified value between 3 and 6 kilograms per square centimeter, the relief valve opens to adjust maximum oil pressure. The oil filter removes fine impurities such as powder and carbon from the engine oil. The filter comprises a check valve, filter element, and relief valve. Oil from the oil pump pushes open the check valve, entering the outer circumference of the filter element. As the oil passes through the element to the filter's center, impurities are filtered from the oil, which is then sent to each part of the engine. If the filter element is closed, the oil pressure at the filter outer circumference becomes higher than that at the center. When the pressure difference becomes about 1 kilogram per square centimeter, the relief valve opens to create a bypass, allowing the oil to flow directly to the engine without passing through the filter element, thereby preventing insufficient lubrication. Engine oil deteriorates faster at higher temperatures. The oil temperature should therefore be maintained below about 125 degrees Celsius. Since the oil tends to become hot, the engine is equipped with an oil cooler like this to lower the oil temperature. Even if there is no oil leakage, the amount of oil will gradually decrease as the vehicle is used, because, among other reasons, oil is burned in the combustion chamber. Oil is also consumed at 3 other points. Between the cylinder and piston, between the valve guide bushing and valve stem, and in the crankcase emission control system.